Alright, geologists, so part 2 of earthquakes. Now, we're going to talk about waves, alright? We're going to talk about 2 types of waves, or actually 4 types of waves, but they can be split into 2 separate categories. Now, when we talk about energy, so an earthquake is a release of energy, right? So your land is locked in, and then boom, it breaks apart, and that releases energy. Now, as energy moves from one place to the other, it moves in what we call waves. This is the sort of wave you're used to seeing, but there's also this sort of wave, and we'll get into those in a second. But the 2 categories of waves we're going to talk about are surface waves and body waves, but we'll get to the body waves in a little bit. Now, with an earthquake, surface waves, they travel across the surface of the earth. That's all it is. And by the surface of the earth, we mean very, very close to the crust. Now, first one we're going to talk about are your Rayleigh waves, which will just R. You can call them R waves and we'll be happy. They are transverse waves. It's this kind here. And it's like the waves at the beach. Okay, so they look like this, and they create a rolling, so R again, rolling wave. So it makes it look like the Earth's doing this. Now, what you actually get is all of the bits of Earth. They don't really move that way. So if the epicenter is here, the energy is moving that way. But all the different parts, they really just move up and down and give you a sort of rolling motion, but they just move up and down. These are the slowest, and they also cause the most damage. So they're slow, but they're powerful. The next one are love waves, or L waves, and these are a longitudinal wave, and that means so as the energy is moving that way, they move in and out like this, and you see that here. So here the parts of the surface are squished together, but then they're going to push apart here, squish together, push apart, squish together, push apart. And again, the particles don't really move very far. They move a little bit, but they kind of stay where they are. They move a little bit, but the energy moves that way. Okay, so here the particles are only going this way, but they come back to the middle, and the energy moves that way. So these are the fastest and cause the least damage, but they still can cause damage. So Rayleigh waves or rolling waves, and they are your transverse waves, and here you have your love waves, which are also longitudinal waves, and they like this. Alright. Brings us back to our body waves, and these are the waves which travel through the surface of the Earth. So if we look up here, the surface waves go along this. Sorry, the body of the Earth. The surface waves go along this way, and the body waves, they travel through, and they do literally travel to the other side of the Earth, and they just travel through the Earth like that. Okay, so again we've got 2 types, and again they're longitudinal or transverse. Okay, so primary waves, the P, they are the fastest, and therefore the first to be recorded, and that's why we call them primary waves. They hit there first. Now again, here we're talking about the Earth from beneath. So the surface ones energy goes this way. These one, the energy goes up. So your longitudinal waves, the rock vibrates this way. Okay, and so up and down. Now it's very important. Okay, push and pull, up and down. It's very important though to realise that the primary waves travel through both liquid and solid rock. Alright, secondary waves. So this actually gives a side-to-side motion, a shaking motion on the surface of the Earth. But again, they're coming up from beyond, but the bottom. But they're that kind of a rolling wave, but going straight up or from beneath. And so they make the rock shake like this, and that's what gives a left to right motion in the house. Okay, the house up there. So secondary waves, they're slower, and therefore the second one to turn up. They're a transverse wave, and hence that sort of shape in the rock. They shake the Earth, and they only travel through solid. Okay, so if that brings us back to here, right? This sort of brings all of the last two lessons together. So here's the focus. Okay, here is the epicenter directly above it. The surface waves, those will be R and L, so Rayleighs and Loves. They're going across the top. And then from this point out, radiating again, like a ripple in a pond. So if the earthquake started here, the surface waves would move out like they do in a pond, like the waves in a pond from when you throw a rock in. Alright, so here's our focus, and you can see the P and S waves moving out in that sort of a fashion until they get to the liquid part of the mantle. Now, in the liquid part of the mantle, so P and S, P and S, P and S, all of a sudden on the other side, only P waves come through. And again, P waves, P waves, P waves, P waves. What that tells us, what that tells us is pretty rad actually. That is evidence for the structure of the Earth. So because we know what these two types of waves will travel through, we know that's easy to work out. Because we can work that out, we can actually work out if we've got enough information about earthquakes and their focus, we can work out not only that in the middle of the Earth there's a chunk of liquid, we can work out at what point. See how it comes down like this? Now it's not big distinct lines, that's a massive radial path coming through this way. We can work out at what point the Earth starts being a liquid, and that's pretty cool. Alright, that's waves. That's some trickier stuff, and we'll reinforce that with some pracs in the next lesson in class. So again, you've got your P waves, your surface waves, your secondary waves, which transverse. Alright, I'll see you in class.